What was that? I better go check that out. I'm coming. Who are you?
I am the ghost of programming past, present, and future.
Wait, like, all at once? Isn't there supposed to be a separate ghost for each?
Budget cuts.
What?
Never mind.
Okay. What are you doing here? What do you want from me?
I am always with you. You have code to build.
To build? To build. No. It can't be! What are you? No. It can't be! Oh man. I've got to stop watching Adventures of Sith before bed. Ugh. Hey folks. I guess I should probably explain all that.
It all started about 6 months ago. I began production of my most ambitious project yet. Well, I can't actually show you. That would be a spoiler. The point is I'm developing the project in C++, and I love C++. It's fast, efficient, satisfying to use, but unlike many modern languages, it does not have its own official build system. It's up to the developer to compile each file manually and link them at the end. And yes, technically it's doable, but come on, we're programmers. Automation is part of the status quo.
Doing your homework? That's helpful. Washing the dishes? Needed to be done. Running for president? That's fun. Becoming self-aware? Wait, hold on. Destroying the human... Border.
There are plenty of third-party build tools, one of the most popular being CMake, and that's what I use in my project, or more accurately, Endured. How do I put this? CMake is the most unintuitive and over-engineered software I have ever used. Well, not the most. Background goes to LaTeX. No, that's not a good thing. Anyways, that's a nightmare for another day. All that's to say, I've had enough of CMake. To be fair, I appreciate what it's trying to do. It's just so je ne sais quoi. That's French for bad. Trust me, I'm Canadian.
Honestly, build systems aren't even that hard of a problem. Heck, I'm a programmer. I could probably just do it myself. In fact, it'd be so easy I could do it in my sleep.
Enjoy a good puzzle? And try and find the hidden keyword somewhere in the remainder of the video, then answer the Cipher question in the pinned comment. Don't like a good puzzle? That's fine too, I guess. Either way, enjoy the show. Chapter 1, the right tool for the job. Before we start coding, it's important to choose the right tool. Just as in the physical world, you need the right tool for hammering in nails and screwing in light bulbs. So let's open up our programmer's toolbox and see what we got. Honestly, C++ is my go-to for system-based programming. However, making a build system for C++ in C++ creates what we call in the programming world a circular dependency.
To compile my C++ code, I'm going to need a build system. Oh, I can make that in C++. But to compile it, I'm going to need a build system. Oh, I can make that in C++. But to compile it, I'm going to need a build system.
Yeesh, that looks rough. Let's check back on them later. What else do we have in here? C's like C++, but, worse. And it has the same build system issue. Python's another popular choice, but I'm not the biggest fan of it. Great for simple one-off scripts, but a pain to manage in larger applications. JavaScript? Yeah, right. I could have used that willingly. Honestly, there's so many languages and tools out there, it can be rather overwhelming. Java, C#, Node.js? What's this doing in here? My advice for people just getting into coding is not to get caught up with the onslaught of languages, but instead focus on the fundamentals. Data structures, conditional logic, etc. These concepts are at the heart of every good program, and are independent from any one implementation. Once you got these down, it's much easier to adapt new languages or technologies. Now concerning my problem at hand, a build system is not a particularly difficult one. Just about any language will suffice here. No, not you. Get back in the trash. In the end, I chose the good old reliable Golang, or Go as the kids say.
And by kids, I mean me. I'm still the kids, I think.
Go is one of those languages that's great when you use it for what it was designed, and frustrating when you use it for what it was not. In my opinion, Go is the definitive tool for web endpoints and parallel computing, of which I'll be using neither. That's not to say Go was bad for this project, I just don't think it lived up to its potential. I initially did choose Go because I thought I could parallelize the compilation, but I ran into issues with overlapping outputs. Ah well, c'est la vie. That's French for something should only be done in serial. Chapter 2, branding, and more branding? Really? That's what we're going with? With the language chosen, it was time to begin the actual project. I decided to start in a less intuitive place, branding. I didn't want to do the whole make thing again, and build just doesn't have that pizzazz. So I consulted a thesaurus for possibilities. Of all the options, one really stuck out to me, cook. And not just because I hadn't eaten lunch yet.
And yes, I eat chips with chopsticks. It's a life hack.
The end result was build chat. If you're a personal building chef, gotta work on that tagline. Build files are called recipes, and the cook command is used to build the project. For a little pinch of charm, additional flavor text is incorporated into the output of the program. Get it? Flavor? Because chef, food, this isn't funny. Who writes this stuff? For example, compiling object files is prepping, and a failure... Remember the brief, man, Jesus. For example, compiling objects is prepping, and a failure results in bad ingredients. Linking the file executable is cooking, and failure results in burnt. Finally, if everything succeeds, it's bon appetit, which is French for I don't actually know. There's plenty of additional flavor text throughout the program, but we can touch on that as we come to it. All in all, the point is little bits of charm like this really go a long way in improving the enjoyment of the experience. That's why I'm so popular with the ladies. Actually, no. No, I'm not. Chapter 3. Read it and weep. Every idea is only good as its execution. This is a quote by Dan Shakespeare, some guy I found on the internet. But I like his quote, for a build system is only as good as its build file. After all, if it's a pain to tell the system what you want, then the whole experience will kinda suck. Hint, hint. Alright, I need to be fair here. CMake's build file, the CMake list.txt, is less of a config file and more of a mini programming language. And that's fine, I'm sure there's lots of projects out there that benefit greatly from this extra power. But then again, the fact that CMake advertises this configuration file as simple on their website does rub me the wrong way. I think this is a classic example of putting the solution before the problem. Yes, CMake files are a powerful tool, but that power comes at the cost of complexity. And I'm not saying every problem has a simple solution. Some things are just complex by nature, like aeronautics, quantum physics, and those space things. But it should be possible, especially in the programming world, to create a simple interface to abstract away the inner complexities of said problem. All that's to say, the complexity of the solution should be proportional to the complexity of the problem. Complex problems can have complex solutions, but simple problems should have simple solutions, and a build system is not a complex problem. It should be simple to say, make me an executable using these source files, these include directories, and these libraries. But it's not. The syntax is so bafflingly unintuitive and over-engineered for what it actually accomplishes. Yet somehow that's not the worst of it. Let me introduce you to the true nightmare, find package. Again, for fairness, I appreciate what this feature is trying to do, automatically finding all paths and libraries needed for a package. And on the upper layer, it's actually intuitive and readable. Congrats, CMake, you finally got some marks. But how does this command actually work? Well, some package finders are included in CMake itself, so no extra code is required. But if you want or need to define your own packages, then you must create this, the find package file. Taking a look inside and... what is this? Seriously, someone please explain to me what this is. I know what it's supposed to be, but no, just no. Good code should be readable. Yes, different languages and different tools have different syntax. But I should still be able to read a section of code and get the gist of what it's trying to do. I read this, and it just makes me want to cry. Honestly, this was the last straw for me. Yes, maybe I could understand it if I'd learned how it works. But again, build systems are not complex problems. I should not need a degree in CMake to build my little C++ project. Now hopefully I'm coming across as critical here and not just whiny. Even so, I'm not asking you to agree with me, but at the very least I hope you can respect my viewpoint, and for the rest of the video, you now have the context for why I designed my build system the way I did. Alright, rant over.
You know, I don't vent that often, but it actually felt pretty good. How did I do? Oh, you lost me. Where? Right after you said chapter 3. So you missed the whole thing? Yeah, pretty much.
Chapter 4. Simplicity is best. I reckon it's my turn. Let's design a recipe file. I really wanted to adhere to the principle I laid out earlier. The complexity of the solution should be proportional to the complexity of the problem. I understand that some projects are complex and therefore can have complex recipes, but some projects are simple and therefore should have simple recipes. And yes, it is possible to have both cakes in this case, or however that saying goes. Recipes are defined by a series of simple keywords. Executable defines the executable, sources list the source files, includes list the additional include directories, static libraries list the static libraries, and shared libraries list the shared libraries. I guess the explanation was a little redundant, but that's kind of the point. the keyword should describe exactly what they do. Of the list, only executable and at least one source file are required. After all, that's the simplest program. More complex projects may need the other keywords, and that's fine, but their existence does not impede the projects that don't require them. In a nutshell, that's how we're able to accommodate both halves of the principle, a rather simple and elegant solution. Concerning quality of life, I've tried to make these keywords as fluid to use as possible. Most keywords, those being sources, includes, and the libraries, have two definition types. If only one entry is required, it can be listed on the same line as the keyword. If there are more entries, they can be listed under the keyword, one per line. The whitespace is actually optional, but improves readability. If the multi-line variant is used, then a path may be specified next to the keyword, and this path will be appended to each of the listed entries. This allows a much more concise way to list, for example, many sources as compared to CMake. Additionally, every keyword, with exception to executable, can be used more than once. This is equivalent to listing all entries under a single keyword, but allows for more flexibility in how the user wishes to organize their recipes. The last keyword is package, and as the name suggests, is my version of CMake's packages. These are essentially sub-recipes, as they use the same format. The main difference is only includes, static libraries, and shared libraries can be defined. The idea is that packages provide an intuitive way to group dependencies together. For example, here's a package file for STL2, ffmpeg, or however you're supposed to say that, and a custom package called native file dialog. Now of course these packages don't provide the find feature that CMake does, but I don't think it's that important of a feature. Listing dependencies explicitly like this is way more transparent about what exactly is being linked. With CMake, I always had to guess exactly what was being included in these packages. In terms of cross-environment support, it's not unreasonable to simply provide different package files for different environments. You wouldn't even need to touch the root recipe. That's not to say BuildChef could never support package finding. I simply find this current solution more than adequate. All in all, I'm quite proud of these recipe files. They're simple when that's all they need, and more involved when it's appropriate.
Normally I like to end a chapter with a skit, but I don't have a joke to make here. Recipes are good. That's it. Next chapter.
Chapter 5, the only hard part. Note that CMake is actually just a generator. It doesn't perform the compilation itself, but merely generates the make files needed to perform the compilation. Although this is a fine concept in itself, our recipes already include all the information we need to compile, so I find it easier just to cut out the middleman. Currently BuildChef only supports G++ as a compiler, but considering the way I've set up the compiler interface, it shouldn't be overly difficult to support other compilers. This list includes GCC for C builds, Clang because I heard that's a thing, and MS Build for Windows builds, which, you know, I don't want to get into this. Let's just say it's a very Microsofty thing that takes something open source, make it a little bit worse, and then try to claim a monopoly on it. Compiling a C++ project consists generally of the following steps. 1. Compile each source file into an object file. This isn't an executable, but simply intermediary code that will be combined into an executable later. And 2. Link all object files and libraries into the final executable. To store the object files, we can create a hidden-ish directory called .bchef in the root of the project. And, you know, this might be a good place to talk about paths. Managing paths to files is a bit of a tricky endeavor. Unlike interpreted languages like Python, where paths are relative to the script files, in a compiled language like Go, paths are relative to where the executable was executed. This can be problematic as it does not give us a definite path from which we can define our source paths. To address this, we can use the recipe file itself as an anchor from which all other paths are relative. On the command line, we can supply the path flag to specify where the recipe is if it's not in the current directory. Effectively, this guarantees the file path is relative to the executable, no matter where we run the program from. What can go wrong will go wrong. This is Murphy's Law, named after Edward A. Murphy Jr., not just some internet guy this time, although its exact origins and phrasing are often debated. Basically, it's a rather depressing way of saying things that could go wrong, given enough time, will go wrong, so plan for such events. In our case, we need to assume that something will go wrong with the project being built, and therefore debugging both the project and the build system should be possible. Errors in C++ are, let's say, less than helpful at times. It's not obvious whether this issue is with the code or its dependencies. Therefore, it's advantageous to inspect the command that was executed, to determine if it contains all expected components. CMake is terrible at this. If you have ever tried to inspect the files that CMake generates, then I'm sorry for your loss of sanity. Trying to make heads or tails of this, let alone locating the build commands, is kinda hopeless. I get these are generated files and not designed for human readability, but that's no excuse. Debugging is a very important part of the development process. So making the build files obnoxiously unreadable is, well, obnoxious. To right this wrong in Build Chef, I have implemented the compile log, a very straightforward log of the exact commands that are executed. Now it's easy to verify whether the commands are as expected. All this sounds great and all, and it is, pat on the back. But there's a catch. See, build systems aren't just responsible for building files, but also keeping track of which files require building. In general, this is straightforward. Simply compare the modified timestamps of the source file and the object file. If the object file does not exist, or is older than the source needs compiling. But this is where things get hard. Dare say the only hard part of the entire program. See, C++ makes great use of this little directive called include. Basically, this tells the preprocessor to copy the entire contents of the include file into the source file. Seriously, that's actually what it does. But therein lies our issue. Changes in the include file can affect compilation, but since the source file was not changed directly, our current system cannot detect it.
So I wanted to use my whiteboard to demonstrate a solution to this problem, but I seem to have misplaced it. Oh, I remember where it is. But to compile it, I'm going to need a build system.
Wow, he's still going. Alright, let's try this.
But to compile it, I'm going to need a build system. Oh, I can make it in C++. But to compile it, I'm going to need a build system.
Wow, he's still going. I actually feel pretty bad for the poor guy. Let's put him out of his misery.
Let's see, which one is it? How about this one? Oh, I can make that in C++. No, that didn't work. I hope that wasn't important. Let's try this. I was gonna eat that. Third time's the charm.
La clé est boucheron.
Ah, this must be it. Well, that's that, I guess. So, this is kind of awkward. After all the trouble I went through to get this whiteboard back, I don't actually think it's the best way to demonstrate this solution. Oh well, let's try something else instead.
The solution to the dependency problem is to treat included files as extensions of the source files. So if any of them change, we treat it as if the source file itself has changed. To determine what includes a source file has, we can open the file and use a little bit of regex to locate the include directives. From there we extract the path. The path itself is relative, not absolute, so we need to join it with each of our include directories in the recipe until we find the file. Once we do, we add it to the list of includes for that source file. Now to make things even trickier, included files themselves may have their own includes, and those includes can have their own includes and so on. We're not going to do the whole loop thing again. Thankfully, we can utilize good old recursion to make the solution, well, possible. The full algorithm for checking if a file has changed is now as follows. Check the modified time of the source file. If it is newer, then it has changed. Do nothing more. If not newer, retrieve the includes for the file. If we have calculated them before, simply retrieve them from memory. I've always parsed the file that calculated includes. Note we only parsed a single file at this time. For each include recurse, this will perform the above steps, check the file itself, and parse includes if needed. This algorithm is rather efficient as it only parses the files it needs to. This is very important, as parsing a file could be rather expensive. You may have also noticed this extra cache variable. This is a disk cache, which saves the includes map to disk after compilation. This call attempts to load the includes for a file from the cache, giving us another way to avoid reparsing files. This call only fails if the cache does not have the entry or is outdated. After that lengthy explanation, you may have a few questions. What if the dependencies change? What about circular dependencies? Does chocolate milk come from a brown cow? Let's answer those one at a time. First, you're right to concern what would happen if the dependencies of a file change. The only way for a file to change its dependencies is to modify the include directives inside the file. But this of course would be changing the file itself, and therefore will be detected by the system before the old includes are ever checked. As for the second question, circular dependencies are a definite concern. This would be where two or more include files reference each other. Recall the algorithm employs short-circuiting, i.e. the function exits if it determines the file itself has changed and does not calculate the includes. Once the file is marked as changed, it will be compiled. If a circular dependency is present, the compiler will detect it and compilation will fail. No object file will be created, no updating the cache, do not pass go, do not collect 200. All that was to say, includes will only be parsed if the source file succeeds in compilation. Let the compiler handle the error checking. Finally, as to the last question, I don't know. I'm lactose intolerant. I should point out that CMake probably does this. I mean, I'm surely just guessing here. But the resulting make file does incorporate include tracking, so I assume somewhere, somehow, CMake implements what I described. The last thing of note is debug control. By default, the project builds in debug mode, as this would be the desired result most of the time. But when it comes time to build for release, simply use the release flag, intuitive and simple. CMake takes a more, well, CMake approach to this, and that's not a good thing. Although it's readable, having to ask ChatGPT what variable I need to set is just annoying. In Build Chef, simply use the help flag with the cook command to list all flags and what they do.
You know, I'm detecting a bit of an unhealthy obsession with this CMake program. Oh, now you're paying attention. Don't you have any other feedback? Perhaps a segue to the next chapter? Well, you've talked a lot about compiling, but does Build Chef do anything else? Or is it just a build tool? Well, I'm glad you asked.
Chapter 6, not just a build tool. What if I told you that good old build last name chef could do more than just build projects? For chefs not only cook, they clean. The clean command is a staple across build systems, as one should never underestimate the value of starting from fresh. Clean will remove all generated objects and executable files. For some extra flavor text, we are scrubbing the dishes, and when complete, it's squeaky clean. A small pet peeve of mine is when programs like, well, I can't think of any examples, make it ridiculously difficult to remove cache files. Caching is great for speed, but there comes a time when things go wrong and maybe, just maybe, you want to start completely fresh from the beginning. So in Build Chef, simply include the cache flag with the clean command to also delete any and all damn it. So in Build Chef, simply include the cache flag with the clean command to also delete any and all cache files. CMake of course does not make this easy, as that would almost make too much sense. It's up to you to delete the cache files manually, and even then it doesn't always work. There are allegedly some rather obscure commands to clean the CMake cache, but even those are iffy. Also note that Build Chef's clean command does require a recipe. Remember, this file is the anchor point for the project, so it's needed to find the hidden ish directory where the cache files are stored. Plus we can read the object files and executable from the recipe. Then we make sure to only delete them and leave all other files alone. The next command is review, for chefs not only cook and clean, they review. Okay, that doesn't really work anymore. feature I wish a lot more applications had, not just CMake, is a way to verify a config is correct. Only relying on compilation to determine if a source file has the correct path is rather annoying. With the review command, the contents of the recipe are printed to the terminal. This way the developer can review the output and make sure the recipe was parsed in the way that was intended. By adding the verify flag, the system will also verify that all flags and paths can actually be found. If it's valid, a green verify will be shown. If not, a red error will tell you what can't be found. The only exception is shared libraries. Strangely, verifying a shared library's existence is a rather complex task. This is highly operating system dependent, and a lot of work goes into managing these libraries, from cache files to sensitive binaries. All in all, I get the impression I shouldn't be messing with this stuff.
Damn it.
Instead, I propose a compromise. Well, technically I don't propose anything, I already implemented it. An optional config file can be created where explicit system paths are listed. I also thought this was a convenient place to specify the compiler, however, again, only G++ is currently supported. During verification, the system paths are used to locate the shared libraries, along with any library paths supplied in the recipe. If the library is found, then great, verified. If not, instead of giving an error, it's just unverified. This does not mean the library doesn't exist, just simply the existence can't be, well, verified. The final command is make. Not to be confused with the other make, although admittedly it is a little confusing. Frankly, I was running out of words. Anyways, creating a new C++ file is a little tedious. You need these things called header guards. Individually, it's not such a big deal, but after creating a lot of them, my soul gets weary. The make command will take in a path to the new files, and generate those header and source files using a template. Add the header flag to only generate the header, and add the overwrite flag to overwrite the files if they already exist. This command was a bit of a last minute addition, but I'm sure it'll come in handy, and if not, it doesn't interfere with the rest of the program. And that's the full roster of Build Chef. It does exactly what it needs to and nothing more. Simple, straight to the point, and intuitive.
Yo, for free CMake, your move.
Fight me!
Oh, you actually moved. I was being rhetorical.
Fight me!
Well, no matter. This time, I'm ready. Build Chef, I choose you. Oh, it's on.
CMake attacks first with poor design. It's not very effective.
Is that all you got? Build Chef, use clean.
That's gotta hurt. But CMake retaliates with unreadable generated files. Still not much effect.
This'll be easier than I thought. Build Chef, use your view. Verify style.
Ooh, they'll feel that in the morning.
How'd you like them commands?
CMake uses cross-platform support. It actually did damage.
Okay, that's fair. That's a fair jab. But now it's time to finish this. Build Chef, use cook. Release mode. Wait, no, it's too much. No!
Oh man, I can't believe that was all just a dream. Well, actually I can. The Smash Bros. Sprite that shred the universe kinda gave it away. Binary Soup Mini presents How to Spot a Dream. Number 1, destruction of the Earth and/or universe. Number 2, destruction of other celestial objects. Number 3, inexplicable changes in outfit. Number 4, ghosts. They're not supposed to be there. Number 5, no, that's actually what I got.
You know, I think my subconscious is trying to tell me something. Maybe my feud with CMake has gone on long enough. I don't really play too much Smash Bros. Probably the former. I got so caught up in why CMake is bad and how Belchef tries to correct it, I missed the most important part. How good or bad something is in the eye of the beholder. Different software is better for different people, and no one, especially some guy on the internet, should tell you what you should and shouldn't use. I made Belchef for my needs, and in that arena it does well, but others may prefer CMake, and that's just as okay. Instead of comparing ourselves all the time, we should be celebrating our differences. After all, the best thing this world has to offer is diversity.
You said it.
Thanks, I'm glad you agree. Wait. Oh man. So this whole video was just a dream? Inside another dream? Well, at least I know this is for real.
Think again.
Go home, folks. This is gonna take a while.
Oh hey, you're still here. I thought I told you to go home. Anyways, at the time of release this channel is still unbelievably small, so if you really did enjoy, consider subscribing. I would really love to see his productions reach more people in the endless content sea. They say there's no correlation between quality and popularity, but maybe there should be. If interested, check out some of the other stuff I've made, or I'll see you in the next one. I guess I should probably finish that project I teased. Steady on.